Students, today we are starting chapter number 12, electricity, for class 10th. Electricity is everywhere around us. Today, in the modern world, we cannot survive for one day without electricity. In this chapter, the first topic is electric current. The definition of electric current is the flow of electron through a conductor. The device which causes the flow of electron through a conductor is called a cell. The electrons flow from the negative terminal to the positive terminal, and the electric current flows from the positive terminal to the negative terminal. This is called conventional current. To understand the concept of conventional current, let us consider a arrangement in which a positive charge plate and a negative charge plate, and a positive charge is flowing from positive plate to negative plate. So the conventional current is the current whose direction is along the direction of the motion of positive charge under the action of electric field. Okay, now consider about the electron. Conventional current due to motion of electron is in the direction opposite to that of motion of electron. Okay, the electric current is defined already as the charge flowing through any section of conductor in 1 second. So the formula for electric current is I equal to Q by T for steady flow of charges, and I equal to dQ by dt for varying flow of charges with time. So there are different type of currents. Number one, steady current, which does not change with time. Second one, you can see from the graph B and C, varying current whose magnitude varies with time. And last one is the alternating current whose magnitude varies continuously and direction changes periodically. And the SI unit of electric charge is coulomb. If we want to calculate the number of electron in 1 coulomb, you have to know about the charge for 1 electron, which is 1.6 into 10 to the power minus 19 coulomb. So number of electron in 1 coulomb is equal to 1 divided by 1.6 into 10 to the power minus 19, which comes out 6 into 10 to the power 18 electrons. And the SI unit of current is ampere. So if we want to define 1 ampere, 1 ampere is the current flowing through a conductor if 1 coulomb of charge flows through it in 1 second. So 1 ampere equal to 1 coulomb divided by 1 second. Electric current is measured by ammeter. It is always connected in series in the circuit. Now the second topic is electric potential and potential difference. Electric current will flow through a conductor only if there is a difference in the electric potential between the two ends of the conductor. This difference in electric potential between the two ends of a conductor is called potential difference. The potential difference in a circuit is provided by a cell or a battery. The chemical reaction in the cell produces a potential difference between the two terminals and sets the electron in motion and produces electric current. Potential difference between 2 points A and B of a conductor is the amount of work done to move a unit charge from A to B. So potential difference is equal to work done divided by charge. V equal to W divided by Q. The SI unit of potential difference is volt. 1 volt is the potential difference when 1 joule of work is done to move a charge of 1 coulomb from one point to the other. 1 volt equal to 1 joule divided by 1 coulomb. Potential difference is measured by a voltmeter, and voltmeter is always connected in parallel. Earlier we have studied about ammeter which is connected in series in a circuit, and voltmeter is connected parallel in a circuit. So it is always connected in parallel across the 2 points between which the potential difference is to be measured. Now, electric circuit. Electric circuit is a continuous and closed path of an electric current. A schematic diagram of an electric circuit comprising of a cell, electric bulb, ammeter and plug key. You can see from the figure. Here is a cell, bulb, ammeter and plug key. Now the symbol of components used in electric circuit, you have to remember all these symbols with their name. So this is a electric cell, and second one is a battery of combination of cell. Battery is a combination of cell. More than one cell is called battery. Now these are the plug key or switches. First one is open, second one is closed. Okay. Now electric bulb is denoted by the symbol like this, and a resistor like this. Variable resistor is also called a rheostat, ammeter, voltmeter, a wire joint, a wire crossing over without joining. Okay. There are a lot of electrical symbols. You have to go through them one by one. Now the next topic is Ohm's law. The electric current flowing through a conductor is directly proportional to the potential difference across the two ends of the conductor when physical conditions such as temperature, mechanical strain, etc. remain the same. So this is the conductor, and we apply a voltage across the two ends of the conductor. The current is flowing through it. So the current is proportional to the potential difference, and when we equalize this equation, we get V equal to R multiplied by I. We get V equal to R multiplied by I, and we plot a graph between V and I. It is a straight line with a slope of 1 upon R, okay, where R is the constant called resistance of conductor. If we take V at x-axis, the slope is 1 upon R. If we take I at x-axis, we get slope equal to R, which is resistance. We get slope equal to R. So to verify the Ohm's law, we have a circuit like this. In this, we have 4 batteries, 4 cells connected one by one. So set up the circuit as shown in circuit diagram. First use one cell and note current I and V. Okay? Then repeat this reading by 2 cells, then 3 cells, then 4 cells, and plot a graph between current and potential difference. The graph will be a straight line. Okay? Now if you calculate the slope of this graph, it is equal to 1 upon R if the potential difference is taken at x-axis. If the current is taken at x-axis, the slope equal to R. Now the resistance is the property of a conductor to resist the flow of current through it. According to Ohm's law, we know that V equal to IR, so we get R equal to V divided by I. The SI unit of resistance is ohm. If the potential difference across the two ends of a wire is 1 volt and the current flowing through it is 1 ampere, then the resistance R of conductor is 1 ohm. Okay, the current flowing through a resistor is inversely proportional to the resistance. So if the resistance is double, then the current get halved. Now the factors on which the resistance of a conductor depends. The resistance of conductor depends upon its length, its area of cross section, the material of conductor. So resistance is directly proportional to the length of conductor and inversely proportional to the area of cross section of conductor. If we increase the length, the resistance is also increases. If we increase the cross section area of conductor, the resistance is decreases. So R is proportional to L, R is proportional to 1 upon L. So when we combine this result, we get R equal to rho L by A, where rho is a constant of proportionality called resistivity of the material of the conductor. This resistivity depends on the material only. The SI unit of resistivity comes out ohm meter. Conductor like metal and alloy have low resistivity like 10 to the power minus 8 ohm meter to 10 to the power minus 6 ohm meter. An insulator like rubber, glass, etc. have high resistivity of the order of 10 to the power 12 ohm meter to 10 to the power 17 ohm meter. Now when we connect these resistors in series like this, when three resistors R1, R2 and R3 are connected in series across AB as shown in figure, the current in all the resistors is same. The potential difference across the resistors is equal to the sum of the voltage across each resistor. So we can write V equal to V1 plus V2 plus V3. V1 is the voltage across R1 resistance, V2 at R2 and V3 at R3. So we can write I multiplied by RS. RS is the equivalent resistance in this series circuit equal to IR1 plus IR2 plus IR3. We can take I common, so we get equivalent resistor equal to R1 plus R2 plus R3. So when we connect the resistors in series, the resistance increases. Now if we connect these resistors in parallel, we get voltage or potential difference across the resistor is same, and the current is sum of the three currents I1 plus I2 plus I3. Now we can write these equation. We can write this equation as V divided by RP. RP is the equivalent resistance in parallel circuit equal to V divided by R1 plus V divided by R2 plus V divided by R3. So we get equivalent resistance equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. Now the next topic is electrical energy and electrical power. Electrical energy is the work done to maintain the flow of current in the circuit. W equal to Q multiplied by V, and we know that I equal to Q divided by T. Q equal to I multiplied by T. So we get W equal to I into T into V. And from Ohm's law we know that V equal to IR. So finally we get W equal to I square RT. This is called Joule's law. The unit of electrical energy is Joule. Now the electric power is the rate at which electric current is used. So power equal to work done divided by time, P equal to W by T, and we already got W equal to I square RT. From here we can get power equal to I square R, and we can write it like this: power equal to I into V. The SI unit of power is watt. 1 watt is the power when 1 ampere of current flows across a potential difference of 1 volt. 1000 watt is equal to 1 kilowatt. 1 kilowatt hour equal to 1000 watt multiplied by 3600 seconds. So finally we get 1 kilowatt hour equal to 3.6 into 10 to the power 6 joule. 1 kilowatt hour is actually a commercial unit of power. 1 kilowatt hour is the power consumed when 1 watt of power is used for 1 hour. Now we study about heating effect of electric current. This is the circuit to study about heating effect of electric current. if a current I flows through a resistor of resistance R and T be the time for which a charge Q flows through it, then the work done to move the charge through potential difference V, W equal to Q multiplied by V, and we know that power equal to work done divided by time. So we get Q into V by T, and Q by T equal to I, so we get power P equal to V into I. Or heat energy supplied equal to P into T equal to V multiplied by I into T according to Ohm's law equal to IR. So heat produced equal to H equal to I square R T. This is actually the Joule's law, I already told you. Now today we stop here and we will discuss the next topic in the next class. Thank you very much. Keep watching. This is actually the Joule's law, I already told you. Energy supplied, a charge Q flows through it. Then the work done to move the charge through potential difference V, W equal to Q multiplied by V, and we know that power equal to work done divided by time consumed when 1 watt of